Ken Jackson, a Ford Motor Company engineer working out of Dearborn. He's been with the company 18 years, designing, testing, researching, problem solving. Right now, Ken's part of a team, visiting technicians across the country. The assignment? To show the dealership technician that using the latest, most effective techniques and the new Volume H supplement is the best way to handle one of the service department's most difficult problems: intermittent fault diagnosis.
Steve, we know that a lot of dealership technicians have been having trouble with intermittent drivability faults. We want to help.
Well, I sure hope you can. It's frustrating. You spend time trying to figure out a problem that doesn't seem to be there.
I agree. You know, as the first step in diagnosing an intermittent problem, it's really important to read the repair order carefully.
Make sure you're certain what the complaint is. Study the repair order. And if you have any doubts, ask the service writer. Maybe the customer mentions something that might help you in diagnosing the problem. Once you're sure of the concern you're trying to fix, do a visual inspection of the engine compartment. In particular, look for areas where electrical wires or vacuum lines could be cut by sharp edges or burned by engine hot spots. Blocked or kinked vacuum lines can also cause trouble. For many technicians, that's standard procedure. You always start with an inspection for any drivability problem. But with an intermittent concern, it's especially important not to disturb anything yet. Don't move any components or connections, or you might make it harder to repeat the intermittent problem.
Let's face it, Ken. Usually the hardest thing about intermittence is getting the car to do what the customer says it does.
Agreed. So the next step is to try to verify the concern. You can repeat the problem in the shop, sometimes, but you usually have to take a test drive to try to verify the concern.
Let's say I do get the car to repeat the symptom. I've had some luck with TSBs.
You're reading my mind, Steve. If you can verify the concern, check the OASIS system or the Technical Service Bulletin Index for any TSB articles that might relate to the symptom and vehicle you're working on.
Okay, but a lot of the time you can't get the intermittent to repeat. And I don't like doing a TSB if I can't see the problem myself.
You're right, Steve. We don't recommend it either. If you can't repeat the problem, you didn't learn anything from the service writer, call a customer and ask him or her about the concern.
What's the customer going to say that isn't already on the repair order?
For an intermittent drivability problem? Maybe a lot. In fact, we've got a checklist of the important points you should cover whenever you talk to a customer about an intermittent.
The first step is to make sure you talk to the driver of the car, not a relative or friend. Get the driver to tell you in their own words what the problem is. Next, find out when the concern happens, including the first time it happened. Get a date and vehicle mileage if you can. Find out if the concern has always been with the car. If it's been a long-standing problem, check to see if it's been approached in a previous work order. Also, ask how often the problem occurs. Get the driver to tell you about the last occurrence and the one before that, if possible. By getting answers to these questions, you may be able to find a pattern to the way the problem happens. It could work something like this sample conversation.
Mr. Daniels, please.
Speaking.
Mr. Daniels, this is Steve Benson at your Ford dealer. I'm working on your car and I have a couple of questions.
All right, go ahead.
To start with, are you the one who drives the car most of the time?
Oh, yeah. I drive it to work every day.
And you've had the car for a year and a half?
That's right.
Good. Now, can you describe the problem for me?
Sure. Sometimes it won't start.
When did the problem first turn up?
Last month.
How many times has the car not started for you?
Well, I haven't been counting, but 6, 7, I think.
And when was the last time?
Just yesterday. Drove to the store. When I came out, it wouldn't start. I called my son to come get me, but by the time he showed up, the car started again.
Can you remember the time before that?
Oh, yeah. I stopped for gas. After I paid, it wouldn't start. Then I got the attendant. He poked around under the hood, and the car started.
Mm-hmm. Mr. Daniels, it sounds like the no start happens after the car's parked for a little while.
You know, you're right. I mean, now that I think about it, it always happens after I drive the car and then park it for a short time. But it starts first thing in the morning every time, and after I've been in the office all day.
I see what you mean about a pattern, Ken. At first, the customer just said it won't start sometimes. But when you ask the right questions, you come to find out the no start is always after a short hot soak.
Exactly. And if you can find a pattern, you'll increase your chances to reproduce the problem and shorten your diagnosis time.
All this stuff sounds good, Ken. What if you can't get anything out of the customer?
I've got a number of other things you can try. Let's take a two-part intermittent fault as an example. Intermittent no start and quits on the road with no restart. We'll go through a complete diagnosis.
Review the repair order. That's where diagnosis begins. You're looking for important clues. And to diagnose an intermittent fault, you'll need as much information as you can get. Go on to a visual inspection of the engine compartment. A visual inspection. Look, but don't touch. Don't disturb anything yet. If the car starts, bring the spark tester along and take the car for a test drive to try to verify quits on the road with no restart. If the car won't start after being parked for a short time, listen for the sound of the fuel pump operating at key up and check spark at the coil. Then, check for TSBs when you get back to the shop. If you can't verify the concern, contact the customer for additional information. Unless what the customer says leads you to some other vehicle system, begin your on-vehicle diagnosis with the ignition system. Start by checking the secondary wires for damage or loose connections. Be sure to include the distributor cap. It has to be checked for moisture, cracks, or salt-like deposits. This cap is in good condition. But compare it to this one. The deposits and moisture in this second cap can cause cross-firing. And cross-firing is a condition that may get worse over time and result in a no-start problem. Next, check the rotor. Look for cracks or evidence of arcing at the center contact. Finally, inspect the TFI module for damage or a loose connection. Damage could result from carelessness, like someone using the TFI module as a fulcrum for prying. That could crack the case or separate the base plate from the distributor. Or, if the connector isn't installed properly, the gasket could fold over. You may have seen this condition and how it can interfere with the electrical connection. Now, let's try a few simple tests to further check out the ignition system. First, connect a spark tester to the coil wire. When that's done, have someone crank the engine. You'll be looking for a good, strong blue spark because that indicates the coil and primary circuit are okay.
Hold on, Ken. I've been doing this for a long time, and we both know I can put the spark tester on one of the plug wires and check the whole system that way. So why not? Why not put the spark tester on one of the plug wires?
That's true, Steve, you could. But we already inspected the secondary circuit pretty thoroughly, so it isn't likely that's the source of our problem. We check at the coil output because we'll see a spark there with every pip signal. That is, if the system's working properly. If there is a fault, we'll be more likely to catch it.
That makes sense. But come to think of it, I've seen guys do this test without the spark tester. You know, just letting the spark go right from the coil wire to ground while you crank the engine.
That's a bad practice, Steve. Without the spark tester, the coil could be damaged internally. And the worst part of it is that the coil damage might not show up until much later.
I see what you mean. You know, Ken, I've seen a lot of no starts caused by bad connections or opens or shorts in the wiring harness.
Well, here's a test that'll help find wiring harness opens and shorts.
Leave the spark tester connected for this test. Then wiggle the ignition primary connectors and harness while cranking the engine. If the spark is interrupted, there is a poor connection that could cause an intermittent no start. An open circuit in the TFI module connector or harness could cause a no start by preventing the TFI module from firing the coil. On the other hand, if the coil primary harness or connector is open, the coil won't fire because it won't receive battery voltage. By the way, when wiggling the ignition harness, be sure to go all the way back to the electronic control assembly inside the vehicle. The next step is to check for secondary leakage around the coil. We'll use a probe with an alligator clip attached. The engine has to be running for this test. We'll connect the lead to ground and then pass the probe around the base of the coil tower. If there's arcing, it's a sure sign of a breakdown in the coil housing insulation. Without good insulation, voltage will leak out of the coil and arc to ground, instead of flowing to the distributor as it ought to. Intermittent leakage of this type could cause an intermittent no start. One more ignition system component we should check is the ignition switch. Bump cranking the engine about 10 times should catch any internal ignition switch trouble.
You know, Ken, those are some good ignition checks. But what if it's the fuel system giving us problems? Last month, I had an intermittent no start that finally turned out to be caused by a corroded fuel pump ground. Took me forever to figure that one out.
I know how you feel, Steve. We've got some ideas on fuel system diagnosis for intermittents that I think you're going to like.
To check fuel pressure when diagnosing an intermittent no start, observe all safety precautions and connect a fuel pressure gauge in the usual manner. You'll have to use an extension hose long enough to reach the windshield, however. A suitable hose was issued in the 1985 tool package. Use 2 lengths of hose if it's easier. They're inexpensive. Tape the pressure gauge to the windshield. Now you'll be able to read fuel pressure from inside the vehicle. Stay away from the windshield wipers and linkage, though. With the gauge hooked up, turn the ignition key to on for 2 seconds and watch the gauge for a pressure increase. Repeat the procedure about 10 times. There should be a 3 to 4 psi increase each time. If fuel pressure doesn't increase in this way, there is some kind of problem in the fuel system. Check the inertia switch, the fuel pump relay wiring connectors, and the fuel pump ground connection for looseness, corrosion, or other factors that could cause an intermittent open circuit. Note that the fuel pump ground is beside the driver's seat under the carpet on many vehicles. There's a TSB that can give you more details. If fuel and spark are good, and you've been able to duplicate the no start, check the spark plugs for soot or fuel fouling. Fouled plugs must be cleaned or replaced if necessary.
I think I see the point, Ken. An engine can't start without fuel and spark, and that's what we checked first. One thing, though. Why not just use a fuel pump pressure and flow test to check the fuel system?
The pressure and flow test is designed for hard faults. You could run the test and get good results without even reproducing the concern. On the other hand, by keying up 10 times, we're more likely to catch an intermittent problem on 1 of the 10 tries.
Well, those are some pretty good answers, Ken.
But what do you think we should try if the checks we've done so far leave us empty-handed?
I'd look at the EEC system.
The Engine Emissions Diagnosis Manual, Volume H, lists the correct steps to prepare for a quick test, including checking coolant level. Low coolant could make the engine coolant temperature sensor send a false reading to the ECA. With preparations complete, run the quick test as described in Volume H. Use the new style Black Star tester that has a beeper for intermittent faults. Write down any service codes. In particular, you'll be looking for continuous codes, the ones that come after the number 10 separator code. Also, be sure to do the timing check. It's step 4 in the quick test. Then do step 5, the engine running test. If you received any continuous codes after the key on, engine off, or engine running test and didn't repair their cause, go on to continuous testing. As part of the pinpoint test in continuous testing, you may have to use the continuous monitor or wiggle mode. And since we're going to use the wiggle mode in a new way later on, let's go over the quick way to enter the engine running wiggle mode. Following the directions in the quick test section of Volume H, enter the engine running test. Immediately after entering the engine running test, unlatch the star tester button, then latch it again. you're now in the wiggle mode. Perform any required pinpoint test in wiggle mode as described in the quick test section of Volume H. During the test, the star tester beeper sounds to indicate an open input circuit. While you're in the wiggle mode, take the cap off the 60-pin ECA connector and wiggle each wire. If there's a short or open in a monitored circuit, the beeper will sound. If continuous testing doesn't identify a short or open, check for and perform any applicable TSBs. If the problem's still there, it's time to prepare the car for another road test. Shut off the engine and make sure the fuel pressure gauge is still properly connected. Also, hook up the black star tester if it isn't still attached. Then connect a breakout box with these key points labeled: battery voltage, reference voltage, throttle position sensor, pip signal, engine coolant temperature sensor, air charge temperature sensor, spout signal, and fuel pump relay ground. The engine supplement section in Volume H will give you the pin numbers. Without cranking the engine, turn the key to the on position and check the labeled key points with a DVOM. Write down the readings you get. Then, repeat the procedure while cranking the engine. Disconnect the coil primary connector so the engine won't start. These readings we take with the breakout box are baseline readings of key voltages while the engine is operating properly. By comparing baseline readings with the readings we get when the symptom occurs, we may be able to isolate the component or circuit that is at fault. After taking the baseline readings, keep the key in the on position and go through the key on engine off quick test. When the test is finished and everything has checked out properly, unlatch the star tester. Before starting the car and going on the test drive, make sure the line to the fuel pressure gauge and the test equipment wires are properly connected and routed to avoid pinching or crimping. And take along the spark tester, the DVOM, and the Volume H. You may need them during the test drive. Make sure there's at least 1/4 of a tank of gas. Then, without moving the key back to the off position, start the vehicle and enter the wiggle test mode. The test drive is done in the wiggle mode. That way, if the star tester detects a fault during the test drive, it will beep, and the code can be retrieved from the memory. As you reach the first half of the test drive, note the fuel pressure gauge reading. The gauge reading should not drop on hard acceleration. If there is a decrease in pressure, there may be a blockage in the fuel filter, a kinked fuel line, or insufficient voltage to the fuel pump. The information from the customer may now help you to narrow down the problem. If the engine quits during the test drive, carefully coast onto the shoulder, but don't move the key from the on position. Now, you must recheck the key points using the breakout box and DVOM. Compare the readings to the ones you got back at the shop. If all of the points are close to baseline readings, latch the star tester and perform the key on, engine off, and engine running portions of the quick test. If the quick test does not detect a problem in the circuits, check for spark. If no spark is detected, disconnect the spout signal connector and check again for spark. Should spark be restored, go to the no start pinpoint test in Volume H. If the spark does not reappear, check for the pip signal. When the pip signal is detected, check TFI and E-core coil circuits for continuity using the DVOM. If there is no pip signal, don't assume that there's something wrong with the pip sensor. Check the crank, run, and ground circuits first. This is the course menu for side 1 of this video disc. Touch the number on the commander for the part of the program you wish to view. Very good. Your answer is correct. That answer is correct. Good job. Sorry, that's not correct. Let's review. Sorry, that's not right. Let's review.
So, Steve, do you think you can use the ideas we've come up with for diagnosing intermittence?
Yeah, I do. And not only that, I'd like to hear what you've got to say about some other kinds of symptoms.
How about intermittent surging at steady speed?
Why not?
Then let's see about some ways to find the cause of an intermittent surge at steady speed.
We start diagnosis with the same steps used for any intermittent fault. First, review the repair order. Second, do a visual inspection. Refer to the emission decal and volume H to make sure that vacuum hoses are properly routed and connected, and that wiring harnesses are correctly connected. The third step is to try to verify the concern with the test drive. If the concern is repeatable, check for any TSBs that might apply. If you can't verify the problem, call the customer and get more information as we discussed earlier. For an intermittent surge at steady speed, you'd want to know at what speed and under what conditions the surge happens. After these preliminary steps, hook up an engine analyzer for some ignition system checks. Check plug firing voltage, cylinder balance, and base timing. In this way, you can identify primary and secondary ignition malfunctions, as well as possible timing problems or rich or lean conditions in any cylinder. When you're done with the engine analyzer test, check the spark plugs for ash fouling, proper gap, and to make sure they're the right type of plug for the engine. That completes ignition system testing. Now, let's go on to the EEC system. Install a Black Star tester and run the quick test as described in Volume H. Don't neglect Step 1, vehicle preparation, or Step 4, the timing check. Incorrect timing could well be the cause of an intermittent surge at steady speed. Be sure to write down any codes received for further reference. The next step is to check the manifold absolute pressure or MAP sensor. Hook up the MAP tester and check the voltage reading with the engine off and the key in the on position. Compare the reading to the correct value listed in Volume H. Repeat the test with the engine running. Bump the throttle during the test. The MAP tester reading should increase. If the MAP tester readings are out of spec, check for leaks, kinks, or blockage in the vacuum line. Substitute a known good hose for the MAP sensor vacuum line. A change in the MAP tester reading indicates that there was something wrong with the original vacuum line.
Ken, that whole MAP sensor test doesn't apply to vehicles with barometric pressure sensors. Say a 2.3 turbo, does it?
No, it doesn't. With a barometric pressure sensor, there's no need for the engine running portion of the test because manifold vacuum isn't applied to the sensor.
That's what I thought. You know, I bet clogged fuel injectors could cause a surging problem. And I've heard about some equipment that can clean injectors. You know anything about that?
I do, as a matter of fact. Let's talk about fuel injector testing and cleaning right now.
To check the fuel injector's operation, we can use this Rotunda fuel injector tester and injector cleaner. The Rotunda unit can both measure fuel injector flow and clean the injector. Following the directions that come with the unit, connect the tester to the vehicle. The tester provides a constant fuel pressure and supplies a fixed pulse width for determining flow. If injector flow is not up to specification, clean the injectors. Use a mixture of 7 parts of clean unleaded gas and 1 part of injector cleaner in the Rotunda unit. Follow the instructions that come with the injector cleaner. After cleaning, test the injectors for flow again. Replace any injectors that still don't meet flow specifications. When injector testing and cleaning have been completed, check the Oasis for related TSBs if you haven't already done so.
Let's say all the steps we've taken still don't point to the cause of the intermittent surge. What do we do next?
Well, we did the preliminary steps. We checked spark and we checked fuel. How about another test drive with all the equipment hooked up?
You got it. The last step in diagnosing an intermittent symptom is always a test drive to try to reproduce the problem and monitor the vehicle while the problem occurs.
First, install a fuel pressure gauge with an extension hose so that fuel pressure can be monitored during the test drive. Then, tee a vacuum gauge and extension hose into the EGR valve vacuum line. Use a 0 to 100 inches of water vacuum gauge. The resolution of this type of gauge makes it much easier to read than one which measures in inches of mercury. Bring the vacuum gauge inside the vehicle where you can read it. Next, hook up the breakout box with the names of key sensor pins marked. Also, install the Black Star tester and route it inside the vehicle. Before closing the hood, make sure the test equipment is securely connected and that the hoses and wires won't be pinched or kinked. Before you start the engine for the test drive, turn the ignition key to on and watch the fuel pressure gauge. Pressure should increase with the key on and as you crank the engine. Run the engine for 3 minutes. Then bump the throttle and watch the vacuum gauge. EGR vacuum should increase momentarily when the throttle is bumped. If vacuum doesn't change, the gauge may not be installed correctly. As a last step before going on the test drive, enter the continuous monitor or wiggle test mode, as we did earlier when we test drove for the symptom quits with no restart. On the test drive, take along an assistant and operate the vehicle in the same way the customer did to try to repeat the problem. For example, if the customer said the surge happened at 50 miles per hour, drive at that speed. Check and record the sensor readings and the gauge readings at the concerned speed with the vehicle running properly. When the vehicle surges, note the readings on the monitors and compare them to the good readings. One of these readings ought to indicate the source of the intermittent surge. The Black Star tester will beep, of course, if the EEC self-test detects a fault.
A little while ago, Ken, you showed me how to diagnose an intermittent no start, or quits with no restart. Sometimes, though, you'll see a car that'll stall out on the road and then start up again. How do you handle that one?
I was just thinking about quits on the road and restarts because the approach we recommend to diagnose it is a little different from the way we attack other symptoms.
Let me guess. You're going to have me do 3 test drives instead of 2.
Not quite, Steve. It goes like this.
As usual, take a good look at the repair order first. Then, do a visual inspection without disturbing anything. As we've done before, we're going to take a test drive now. However, the symptom requires that we do it a little differently this time. Since we may have only one chance to reproduce quits with restart, we're going to take along some equipment on the first test drive. Install the fuel pressure and vacuum gauges to monitor fuel pressure and EGR vacuum levels during a stall. Also, connect a lead to the vehicle power circuit of the ECA. Then hook up the DVOM to monitor battery power to the ECA during the test drive. Start the vehicle and check the idle speed, following the procedure in Volume H. As you go through a short test drive, check the vacuum and fuel pressure gauges and the DVOM occasionally. If the car quits, check the gauges and DVOM for any signs of trouble with EGR vacuum, fuel pressure, or battery power to the ECA. Back at the shop, check out any signs of trouble you saw on the test drive. For example, if the power to the ECA was interrupted, check the circuit for shorts or opens. You should also make sure the EEC power relay is working properly. Check the fuel pump connection at the tank if there was a loss of fuel pressure during the test drive. Also, check for any TSBs that might apply. Start with the ones that relate to what you observed on the test drive. Of course, as is often the case, you may not have been able to verify the problem. Your only option then is to call the customer to get a better description of the problem and how and when it occurs. Be sure to use the customer contact sheet included in the Engine Emission Diagnosis Manual Supplement on intermittent faults. Follow up any leads you get from the customer. Then check out the EEC system by performing the quick test as described in Volume H. During wiggle testing, check the connections at the ECA as we did previously for no start.
You know, Ken, at first I thought we were going at this intermittent in a different way from the others. But the more I think about it, the more it looks like the same procedure. The only thing that changed was that we hooked up the gauges and the DVOM on the first test drive. Does that mean we don't need another test drive?
Well, not quite, Steve. We still need the usual test drive in wiggle mode if nothing we've tried so far locates the fault.
To get ready for the next test drive, install the breakout box with key pins labeled. Route the Black Star tester inside the vehicle and enter wiggle mode. Then drive the car. If it quits, don't touch the ignition key. Coast to the shoulder. Recheck the key elements on the breakout box and run the quick test.
Ken, I'm really getting to like your ideas on diagnosing intermittent faults. I can already see how I'll be able to save some time in the future.
Many of these ideas actually come from questions raised by technicians across the country. We've tried to use the technicians' suggestions, along with some of our own, to make intermittent fault diagnosis as quick and simple as possible.
Let me try you on another intermittent problem, bucking and jerking.
Okay, you'll see a lot of familiar steps for this one.
Start with the usual first few steps. Review the repair order. Inspect the engine compartment visually. Verify the concern with a test drive. Check the TSB index or OASIS and call the customer for additional information. Next, check the ignition system using some of the same steps we used before. Inspect the distributor cap and rotor for corrosion and damage. Also, inspect the wires and connections. Check the coil for secondary leakage too. And check the continuity of the coil primary and secondary circuits. Then, hook up the engine analyzer for ignition system testing. Be sure to include the cylinder balance test. When these ignition checks are finished, connect the Black Star tester and run a complete quick test. Remember to clear the E-System continuous memory when you're done with the quick test. Leave the Star tester connected. The last step in the shop is to test the map sensor for proper operation at your altitude. Now, it's time to prepare for the final test drive. As always, connect the breakout box with key pins labeled and bring the Star tester inside the car. As we've also done before, install a vacuum gauge to monitor EGR vacuum and a pressure gauge to check fuel pressure during the test drive. For this test drive, we'll also want to monitor manifold vacuum for information on base engine operation. Route the gauge and hose inside the vehicle as you did with the gauge monitoring EGR vacuum. Before you actually drive the car, turn the key on and off and watch the gauge to see if fuel pressure rises. Then, as you crank the engine, the fuel pressure should rise to the proper specification. Also, after the engine has run for 3 minutes, bump the throttle and make sure that EGR vacuum increases when the engine speed does. Finally, enter the engine running wiggle mode and set the radio to the low end of the AM band. This checks for internal arcing in the coil, since the arcing would be picked up as noise on the radio. With all your equipment in place and properly connected, begin the test drive. Try to drive the car just as the customer said he did when the bucking and jerking happened. If the concern does happen, check all test equipment readings. A beep from the Star tester means you'll have to run a key on, engine off test to retrieve the continuous code back at the shop.
I really appreciate the time you've spent going over these intermittents with me. But there's one last problem that we could use some help on.
And that is?
We sometimes get a vehicle in that runs erratically and has a rough idle, and we have a hard time isolating the problem.
All right, let's run through the first few steps together.
Begin diagnosis with the usual steps: reviewing the repair order, inspection, test drive, TSBs, and customer contact. After these initial steps, there are a number of things to check in the shop for a rough idling or erratic running engine. Some only apply to certain engines. For instance, on multi-point fuel-injected engines, make sure all the injectors are the same color. If a high-output injector got mixed in with regular injectors, it could upset the air-fuel mixture and cause a rough idle or erratic running. Refer to the Volume H supplement on intermittent fault diagnosis for the right injector color for each engine. For all vehicles, go on to check out the ignition system. Inspect the distributor components for corrosion, salt-like deposits, moisture, or damage. Next, check the ignition system with the engine analyzer. Be sure to check engine timing. If the timing is not solid and within specs, check for a loose camshaft thrust plate or loose camshaft gear. Also, run a cylinder balance test. Then, inspect the spark plugs for deposits and correct gap, and make sure they're the proper type. And while you've got the plugs out, do a compression test to check for proper engine and valve train operation. After the compression test, go on to check the EEC and ignition components. Check the TFI module, profile ignition pickup, and coil by following the TFI worksheet provided in the EEC Certification Training Program reference book. Be sure to use a test light with low current draw to avoid damaging the electronic control assembly. Then, check to make sure the spout connector is properly seated. If it's not, the spark output signal may not reach the TFI module, and then timing wouldn't be advanced when it should be. And check the coil for secondary leakage or external arcing. With most of the non-EEC items checked, perform a complete quick test. Then, check out the MAP or BP sensor as we did earlier. Now that we've done everything we can do in the shop, it's time to get ready for another test drive. We'll need the same gauges as we used for the symptom bucks and jerks. Fuel pressure, EGR and manifold vacuum gauges installed in the usual manner. Of course, we'll want the EEC system to be in the engine running wiggle mode, and we'll set the radio at the low end of the AM band again to check for noise from ignition system high voltage leaking or arcing. The last monitor to be hooked up is the labeled breakout box. Before starting the car, turn the ignition key to the on position and make sure that fuel pressure rises sufficiently. Check fuel pressure when the vehicle is started, and then check it occasionally while the car is idling. Idle the engine for about 3 minutes, keeping an eye on all the monitors. Then bump the throttle to check the EGR vacuum gauge installation as we've done previously. Take along an assistant on the test drive to monitor engine operation. Make sure to drive in such a way that the customer concern is most likely to be duplicated. Watch all your equipment carefully. One of these monitors should help to identify the source of the intermittent fault when the customer concern is reproduced.
Well, what do you think, Steve? Have the checks we've gone over on intermittence been worth the time it took?
For me, it has. If the ideas you came up with can save me some time on a job, well, that's money in my pocket. Makes the customer happy, too. Get the car fixed and fixed quicker.
Now, is there anything you want to go over again before I leave?
Just one thing. I think I understand the basic approach to diagnosing intermittent faults, but could you spell it out for me just one more time?
Sure.
The preliminary steps are the same in all cases. Review the repair order. Make a visual inspection without disturbing anything. Test drive to verify the problem. Refer to TSBs if you can verify it, and call the customer if you can't. Then go on to some diagnostic checks in the shop. These may differ from one symptom to the next, but you'll always check fuel and spark, and of course, you'll run an EEC quick test. If you can't repeat the concern any other way, test drive the car with test equipment attached.
And I've always got Volume H and the supplement on intermittent faults to help me.
I think I know one dealership that's going to have a lot less trouble with intermittence.
If you have already viewed side 1 of this video course, touch 1 on the commander to go on. If you have not viewed side 1, touch 2 on the commander to exit the course. Then turn the disc over and view side 1 before viewing side 2. This is the course menu for side 2 of this video disc. Touch the number on the commander for the part of the program you wish to view. Very good. Your answer is correct. That answer is correct. Good job. Sorry, that's not correct. Let's review. Sorry, that's not right. Let's review.